sequence using your calculator. That's your calculator. So we'll be starting off with question 20. That's finding the sum of an n term of an AP. So the question said that find the sum of the first 40th term of the arithmetic sequence, which was given as 17, 24, 31, 38. So the trick behind solving this is that whenever you're talking about series, that's sum of the sequence, right? So easily you can use your summation notation to solve it. This is for that summation is with respect to sum of the sequence, but you might be have to do just a little bit calculation, which I believe all of us are actually familiar with. So any sequence, be it APGP, has a unique n term, which is always gotten from the general n term of the sequence. So obviously, this is an AP, right? And the general n term of an AP is given as Tn equals to a plus n minus 1, then close the graph. So don't say the content and you write your D. Sorry, I meant D. As simple as that. So as we already know that A represents your first term and the D, sorry, I mean common difference, represents your common difference, like your D represents the common difference, right? And in this particular question, we're given the sequence as 17, 24, 31, and 38. And your common difference is your current term, that's Tn minus 1, which means T3 minus T2 equals to T4 minus T3, and it continues like that. So obviously, you observe that this term or this sequence is increasing by us adding 7 to each of the term, like 70 plus 7, 24, and it continues like that, right? In the sense that it has a common difference of 7, which is gotten as 24 minus 17, that's 7, 31 minus 24, which is the 7, and 38 minus 31, which is the 7. You can say it is common, like it is persistent, and it is the same. So obviously, you know that our D is 7, and our A, which represents your first term, which is what? 17. So easily, just impute the value of your A and the value of your D here, and you simplify, then you have what you call your unique n term. Unique in the sense that it is peculiar to that particular sequence. So doing that, we're having our Tn equals to 17 plus into the bracket n minus 1, close the bracket 7. So let's expand this sheet. So we have 17 plus 7 times n, that's 7n. Then 7 times minus 1, that's minus 7. Then easily just simplify, that's 17 minus 7 plus 7n, right? And here you're having 10 plus 7n. So this is what we regard to as our unique n term. We're also using it when we are solving using our calculator. So that's the first thing for you to articulate while solving for some of the sequence. So now back to our calculator, which we have here. So just click on your summation sign. How do you do that? Take a look at this log here. At the top of it, you'll see the summation sign here. There's it here. So this is what you call summation. I believe we have come across that before. So just press your shift and that log. So you can see now we have summation. Then we have some blank that we are here to fill in. So let me just brush it through. So this brown you are looking for, you like this particular blank here. That is where you record or you're going to enter the unique n term you have. That's the 10 plus 7n, right? Then this bar at the top of the summation, we call it your upper limit. That's when you stop the summation from, like upper limit deduced. Then this last one here, that's your floor, your lower limit. We call this where you are starting from. And you know, some always start from the first term, right? So a particular nth term. So your x will always be equals to 1, like your lower limit is 1, and your upper limit, which will be given in the question, and in the middle you have your unique nth term, right? So this x here represents index of the summation. It can be represented with different variables. You can see it as I, you can see it as j, you can see it as k, but here it came as x, right? So there will be a little bit of modification we'll also be doing this. Instead of writing 10 plus 7n, I'm writing 10 plus 7x. This n will be a function of the variable I have here, like the index of the summation, just a little bit modification. So now let's enter the necessary information. Before that, let's go through the question once again. We were told to find the sum of the first 40 terms, right? That means our upper limit will be 40. That's what we want to stop summing from, right? Now lower limit to be what? 1. We want to start from the first term down to the what? 40 term. So my upper limit, so let's enter the unique n term first. That's 10 plus 7. Then you have your alphabet and close brackets for you to write the x. Then you can just then you move it to the down part. We have 1. Then the upper part we have 40. That equals to, boom, we have our answer without stress. That's 6,140, which is option D. As simple as that. So let's try out one more question on that. That's question 21. We're told to find 2 plus 4 plus 6 plus 8 plus, that's to infinity. But here we're told to find the sum of the first 25th positive integers, right? That's sum of the 25th term of that particular sequence. So let's do this again. We're having 2 plus 4 plus 6 plus 8. Obviously, you'll agree with me that this is an AP. Due to the fact that it is each sequence is increasing, or each term rather is increasing by me adding 2, right? Like that's a common difference, which is 2. So our common difference here, that's 4 minus 2, that's 2, 6 minus 4, which is still 2, and 8 minus 6, which is still 2. So we have our D as 2, and we have our A as what? 2. So still applying this, that's Tn equals to A plus N minus 1, close the bracket D, when A is 2 and D is 2. So we have Tn equals to 2 plus N minus 1, then close the bracket 2, right? So simplify this, we're having 2 plus 2n minus 2. Then for that simplification, this will cancel out, then we're having 2n. So this is what we're going to regard to as our unique nth term. So now applying that, so our shift again and our summation. So here we have our 2n, but here we're writing 2x as we initially did. So here we have, so here we have 2, then we have our alphabet and x. Our lower limit remains 1 and our upper limit remains 25. Then equals to, boom, you can see 650. That is option 650. So that is option C. So that's for AP. So now let's talk about finding the sum of n term of a GP. Still the same process, like still the same step. The only modification here is that us finding the unique n term. You all agree with me that the nth term of the AP is quite different from the n term of the GP, right? So as I've initially stated, like all terms, be it AP, GP, or Fibonacci, always have a unique n term, which is always got it from the general n term of that sequence, right? So let's take a look at question 16. We are told that find the sum of the first 11 term of the geometric sequence 7, 14, 28, 56, and 112, right? So that is very straight to the point. They've told us that it's actually GP. That's a geometric progression. So we're giving it as 7, 14, 28, 56, 112, then that's an indefinite sequence. It continues. So we are going to agree that the n term of a GP, that's your Tn, is always given as AR raised by n minus 1, when A represents still the same as your first term, and the R represents your common ratio, right? So for the first thing first find is find our A and find out common ratio. Obviously, our first term here is 7, right? In the sense of A equals to 7, but our common ratio, when you hear the word ratio, is with respect to division, right? So common ratio, which is the R, is Tn, that's the current term, divided by the term before, in the sense of T3 divided by T2 equals to T4 divided by T3. Like the difference is common, it is regular, it is the same. So we are having 14 divided by 7 equals to 28 divided by 14. Obviously, this is giving us 2, right? So meaning that our R is equals to 2. So applying that here, we're having Tn equals to our first term, which is 2, which is 7, right? Here, and our common ratio, which is 2. So I'm having 7 times 2 raised to power n minus 1. Please don't make the mistake of multiplying. This here is not the same thing as 14n raised to power minus 1. They are quite different. So your final answer of the unique n term here is this, not this. So this is actually wrong. So don't make the mistake of multiplying. So now over to our calculator. So we are told to find the sum of the first 11 term of the geometric sequence in the sense of our n equals to 11, right? So here we have shift and our summation, right? So at the center, you still have unique n term, that's 7, then just press times, then we have 2, then power, then enter the variable. Instead of n minus 1, I'll be having x minus 1. So alphabet and x, then I have minus 1. As simple as that. Then the lower limit remains 1 and the upper limit is 11. Then press to equals to, boom, you have the answer 14,329. That's option A, as you can all see. So same goes to question 17 too. We're told to find the sum of the first systems of the geometric sequence, which was given as -5, -15, and -45. So obviously here our A equals to -5, right? And our R, that's -15 divided by -5, which will give us +3. So we're having it as 3. So Cn, still applying our n term of a GP, A -5 times R3 raised to power n minus 1. As simple as that. So over to our calculator again. So we have our shift and log. Then you'll be having -5 times 3 raised to power x minus 1. Then our lower limit remains 1 and our upper limit is 6. Then equals to, so we have our answer, that's minus 1820. That's option C, as simple as that. So thanks for watching.